Here the set S is equal to 1 omega omega square, where omega and omega square are the cube roots of unity. Star is the multiplication operator. Then the structure S comma star forms what? See, in order to form a group, it should satisfy four property. For group, there should be closure property should be satisfied, associative should be satisfied, there should be existence of identity element, and there should be inverse for every element in the group. Now we will check one by one every property. First, closure. Closure says that take any two element from the set 1 omega omega square, multiply it. If the result belongs to the set S itself, then the closure will be satisfied. 1 into omega gives omega and it belongs to set S. Now omega into omega square is equal to omega cube. Omega cube is equal to 1 and 1 is present in this set. No problem. Now omega square star 1 is equal to omega square and it present to set S. No other combinations are possible for multiplication, so closure property is satisfied. Second, we will check associativity. Associativity means 1 star omega multiplied with omega square, whether equal to 1 omega omega square, whether they both are equal or not. Let's check. 1 into omega is omega into omega square, it is omega cube. Now omega into omega square is omega cube into 1 is equal to omega cube. So both are LHS and RHS are equal, so associative property is satisfied. Associative is satisfied means it is a semi group. Closure is satisfied means it is a algebraic structure. Third property, we will check whether there is identity element present or not. Since set is 1 omega omega square, for multiplication identity element is always 1. Identity element means any other element x belonging to set S, x star e should be equal to x. So e is equal to 1 is the identity element of set S. So structure S comma star is monoid. Now we will check fourth property, whether inverse of every element is present or not. Since we know that identity element is 1, identity element is inverse of itself, is inverse of itself. Every identity element is always the inverse of itself for any structure. Now remaining are two elements, omega and omega square. Inverse means for x star x inverse should be equal to identity element. Inverse of x means when inverse of x multiplied with x, we will get the result as identity element. Omega when multiplied with omega square, we will get omega cube, which is equal to 1, means omega and omega square are inverse of each other. Since every element in the set has inverse, so inverse property is also satisfied. So this structure is group. So option A is correct.